For our first section in Unit 2, we're going to look at solving linear equations. Your essential question for today is, how can I solve linear equations? Now, I've put together some steps for solving linear equations, and if you follow these steps in order every time, you should feel confident about solving any different type of equation. So step number 1, if you follow my laser, we need to get rid of our fractions and our parentheses first. That's going to be imperative. To get rid of fractions, you're going to multiply everything by the LCD. So every term, whether it's a fraction or not, you multiply by the LCD and all of your fractions should cancel. B is parentheses. If you need to get rid of parentheses, you're going to use your distributive property. And I'm going to show you examples of both of those so we can go over that. Our second step is we're going to start putting our like terms together. Now, it's really important that you know when to use the inverse property and when not to use the inverse property. If you're moving over the equal sign, you're going to do the opposite or use the inverse property. If you're putting like terms together that are on the same side of the equal sign, in other words, if you're not moving over the equal sign, you will not use the inverse property. And then step 3 is you solve for the variable. Let's go ahead and look at a couple examples here. For the first example, I've got 6 minus the quantity k minus 5 plus 3k equals k plus 6. Now, the first thing that we need to do is we need to get rid of any parentheses or fractions that we have. If you'll notice in this problem, we have a parenthesis, so I need to get rid of that parenthesis by using my distributive property. Now, what am I distributing in? I don't see anything on the outside of this parentheses. Well, remember, there's a negative 1 there. Anytime you've got a negative sign, there's a negative 1 there. So that's what I'm going to be multiplying in. So it becomes 6. Negative 1 times k is negative k. Negative 1 times negative 5 is positive 5. And then I carry down the rest of the problem. Plus 3k equals and k plus 6. There are no fractions, so I don't need to worry about fractions. Step 2 says, put your like terms together. Well, I'm going to start by everything on this side of the equal sign. So I'm just going to focus on this side of the equal sign. And I notice that I've got a negative k here, and I've got a positive 3k here. Now, there is no equal sign in between these two guys. I'm not moving over the equal sign, so I'm not going to do the opposite. This is just negative k plus 3k. Well, negative k plus 3k is positive 2k, or you could look at it as 3 minus 1k. Okay, same thing with my numbers. I've got a 6 and a positive 5. There is no equal sign in between them, so I'm not going to use my inverse property. I'm just going to put them together. It's a positive 6 plus 5. It's 11. Now, looking at the other side of the equal sign, I don't have any like terms that need to be put together. The k plus 6 stand on their own. I'm not done. I still need to put my like terms together. And now I'm moving over the equal sign. Let's start with our k's. I've got a 2k over here and a positive k over here, separated by an equal sign. And that's really important because that gives us permission to use the inverse property. So I'm going to go ahead and move this k over to my 2k. Now, to do that, it's a positive k. I'm going to use my inverse property of a negative k, and what's going to happen is that's going to cancel. 2k minus 1k is just 1k. Same thing with my numbers. There's an equal sign separating them. Now, I know that I'm going to move my 11 over to my 6 to get it away from my k, and since there's an equal sign separating them, I can do the opposite. In this case, positive 11, the inverse property says negative 11. 6 minus 11 is 5, and it's a negative 5 because we moved into the negative. And our answer is k equals negative 5. What does that mean? That means if I plug this negative 5, if I plug that negative 5 back into the original equation for any k, I will get two sides that equal each other. All right, let's look at example number 2. In example number 2, we've got some fractions. So let's go ahead and look at this. The first thing you need to do is get rid of fractions. If you look back at the steps you wrote on my first slide, you've got to get rid of these fractions. And the way that you do that is you multiply every term by the least common denominator. So our denominators in this case are a 6 and a 2. Those are the denominators we've got. We've got a 6 and a 2. And I've got to ask myself, what's the smallest number that both of them multiply into? Well, a 6 multiplies into 6, and a 2 multiplies into 6, making 6 my least common denominator. So what I'm going to do is I'm going to multiply the top and bottom by that, or excuse me, not the top and bottom. I'm going to multiply each term by that 6. Now, when we multiply into fractions like this, we're multiplying in the numerator. So I'm going to rewrite this problem as 6 times x plus 7 over 6, 6 times 2x minus 8 over 2 equals negative 24. So what I've done is I've multiplied that 6 into the numerator of all of these numbers. In other words, I've made all of them 6 times bigger, keeping them equal. If I made him 6 times bigger and him 6 times bigger and him 6 times bigger, they're still equal. Now what's going to happen is they're going to cancel. So 6 and 6 cancel right here, just leaving me x plus 7. 6 and 2 are going to cancel here, but what's 6 divided by 2? It's 3. That's going to leave me a 3. And it's 3 times the whole thing, so I keep my parentheses. And I already multiplied the 6 times the negative 4 right up here to get me negative 24, so that just stays negative 24. Now we've got a problem that we can solve. So the first thing I need to do now is get rid of my distributive. And then I need to put my like terms together. So I'm going to start by using this side of the equal sign. Remember, there's no equal sign separating these. So when I put my like terms together on this side, I'm not going to use my inverse property. So x and 6x is just 7x. 7, take away 24, it's negative 17. Now we're going over the equal sign. Now we're going to put our like terms together over the equal sign, and I notice I want to get my numbers out of here. Since we're going over the equal sign, I can go ahead and use my inverse property, and I can add that 17. I'm running out of room, so I'm going to scooch over here a little bit, leaving me 3, 4, negative 7. And then once again, I'm going to use my inverse property. It's 7 times x. Opposite of times is division. I'm going to get a negative 1. Now you guys will remember for the last couple of problems we got k equals negative 5, and I think for the last one we got x equals negative 1. These answers are considered conditional. Now this vocabulary word is going to be important and you're going to be tested on it. Anytime you get one solution that works for that equation, so one solution that works for that particular equation, the answer is considered conditional. You are tested on this vocabulary word. It's important that you understand. So anytime you get one correct answer, it's conditional. So the question then becomes, what happens if you don't get one correct solution? It's not conditional. Let me show you what this looks like in college algebra. I'm going to solve both of these problems parallel, and I want to show you the difference. So let's start over here. The first thing I'm going to do on this problem is I'm going to use my distributive property. I'm going to multiply that 5 in. I get 5x minus 15 equals 5x minus 15. So the next thing I'm ready to do is move over the equal sign. And since I'm moving over the equal sign, I'm going to go ahead and do the opposite. I get 5x equals 5x. Okay, same thing. I still want to do the opposite and put my x's together. I can going over the equal sign, so I'm going to use my inverse property. I get 0 equals 0. In other words, my x canceled out. Now, because my x canceled out and my solution was correct, this is called identity. So the x canceled, my solution was true. 0 does equal 0. My solution is true. This is called identity. The vocabulary word I want you guys to focus on is identity. That's the word you're going to have to know. Now let's look over here. What happens if it's not true? What happens if x cancels but the solution is not true? Well, let's look at what that looks like. So same type of problem. I'm going to put my numbers together first. I'm going to add my 15 over. Put my x's together. I get to use the inverse property again. I'm moving over the equal sign, and I get 0 equals negative 5. Now let's look at what happened. My x's canceled. But what I'm left with is 0 equals negative 5. Well, 0 does not equal negative 5. This solution is untrue. When the solution is untrue and the x cancels, it's called a contradiction. Contradiction. Now you guys are used to the words all solutions and no solutions, but since we're in college algebra, we're not going to use that vocabulary terminology anymore. We're going to use the word identity and contradiction. for the third time, you are tested on this. You need to make sure you know these vocabulary words. Make sure you get them in your notes.